Welcome to CHM 260 introductory video where all the fun begins here. This course will expose you to the theory, application and basic instrumentation for chromatography, which are GC and HPLC. Next, molecular absorption spectroscopy for ultraviolet visible and infrared FTIR. Lastly, the type of atomic spectroscopy involved are flame atomic absorption spectroscopy AAS and flame atomic emission spectroscopy AES. Now, let me take you to a situation of a crime scene investigation where you could have a closer view about how the instruments mentioned before works.
Sedang medis 1 bus, sedang MECC, sedang medis 1 transport.
This is an example of a real-life situation at a crime scene investigation. We as a chemist functions to help the forensics in conducting lab analysis of the evidence collected. Now let's move to the laboratory to find out more about the process and handling instruments.
GC is an analytical instrument that measures the content of various components in a sample. The analysis performed by gas chromatograph is called as gas chromatography. During analysis, components of a sample are dissolved in a solvent. It is then vaporized to separate the analytes into two phases, stationary and mobile phase. UV vis is the measurement of attenuation of a beam of light after it passes through a sample or after reflection from a sample surface. Used to measure intensity of light passing through a sample and compares it to the intensity of light before it passes through the sample. AAS determines the concentration of a particular element, metal, in a sample using the absorption of optical radiation by free atoms in gaseous state. HPLC separate, identify and quantify components in a mixture by pumping a sample mixture in mobile phase at high pressure through a column with chromatography packing material, which is the stationary phase. FTIR is an analytical instrument for detecting functional group in a sample. The analysis will produce infrared absorption spectrum. From the spectrum, there is a range of wave numbers which also represents the frequency range. From there, we can determine the type of bond or functional groups. Therefore, from what you have seen, this course will teach you how to relate the principles and terms and perform calculations used in spectroscopy and chromatography. Secondly, state and explain the major components as well as their functions in both spectroscopy and chromatography. Third, analyze chromatograms and spectra qualitatively and quantitatively. Next, conduct experiments and relate data to the theory of chromatography and spectroscopy. Lastly, write a scientific report on the experimental findings. The next slide will give you a head start on what topics you will learn. First, an introduction to spectroscopic methods of analysis. Second, molecular absorption spectroscopy, theory, instrumentation, and application. Third, atomic spectroscopy based on flame atomization, theory, instrumentation, and application. Fourth, an introduction to chromatographic separations. Fifth, gas-liquid chromatography. Lastly, high-performance liquid chromatography. I believe that you think that this course is fun, right? What are you waiting for? Buckle up and continue your journey to become a great chemist by visiting the links below. Thank you. See you in the lab.